accidentally told y'all that it was jolt and it's actually jerk.
It's jerk?
Yeah.
That's what it was in the notes. Did you do 3.5 notes?
I will. I have
You're gonna be so incredibly lost.
Yeah.
I'll go ahead and use my birthday back.
I don't care. I'm just telling you, you're going to be lost.
I gotta do some work this weekend. I've been behind on like everything.
What'd you do at the library?
I
Oh,
literally,
it's
I've worked writing these things, like these cards for her. Like she had a little card with like a ton of stuff written on it, and I had to like copy that, duplicate it, and it took me 2 hours. So in the last hour, I was just like helping my mom like set up wherever she was going. I don't know.
That's funny.
I was so upset when I got to go home from that yesterday.
Okay, so perhaps we should give Virginia a rundown of the trig derivatives real fast.
Instead of derivatives, I wrote derivates.
At least didn't say
Does this one still make you mad, Josh?
It was just very surprising. It's like okay, so it's cosine, right? And then we have negative sine of x, okay. And then we get to secant squared of x, and it's like, how in the world do we get to that?
Well, did I derive any of them for you?
Only the sine one.
But, like, I didn't explain how to get to, like, tangent if you don't remember what tangent is.
I think you did explain.
Oh, okay.
Yeah, like it's
Like, tangent is sine over cosine, so we can use the quotient rule and find it.
yeah. But then there's negative cosecant of x and cotangent of x. It's like, what in the world? Why is it like that?
Yeah.
Are these just like things we have to know? Or like, are there ways to?
You don't want to have to solve for those.
Yeah, you need to memorize them.
Do you know when our unit circle thing is? Is that soon?
I usually do it as a surprise.
Someone remind me to study that this weekend.
How you solve for the derivative of the sine of x. So
It's not pleasant, so I suggest memorizing them. However, if you know sine and cosine, you can pretty much solve for the other ones a little easier than that, but you have to know at least those two. Alright, so y prime. So we treat this just like when we have like 2x, it's just 2 sine x. So we take the derivative of sine of x, which is cosine of x, so this is just going to be 2 cosine x. Minus derivative of tangent is secant squared, so secant squared x. And a lot of times I'll just say derivative of sine is cosine, derivative tangent secant squared. Like, I'm not going to say if theta or x, I just usually just say it and just know that. Because if there's anything but just an x inside, then we have something completely different happening. That's 4.1.
Okay. Let's say, is that this section?
No. It's called the chain rule, and you don't know what that is yet. So, because if you can't do these, you can't do the chain rule. Or like this chapter, you can't do the chain rule. All right, y equals 3x plus x tangent of x. So we take the derivative of 3x, which is
3.
then over here, what's happening?
so the tangent of x is multiplied by x.
Yeah, these are being multiplied, so I have a product rule. So x times the derivative of tangent of x, which is secant squared, plus derivative of the first one times tangent of x, and that would be your answer. So not too bad, right?
If I remember the product rule, then
You're going to need the product rule
rule's
and the
going on
quotient rule.
inside, right?
The insides, yeah. But the product rule technically can go either way. It's not going to make a difference, technically. Quotient rule will make a difference if you do it wrong.
Quotient rule, I just have to remember that's u prime first.
Speaking of the quotient rule, let's do it.
I keep wanting to like solve these like how we had to do it last year where it was like trying to make it like as small as possible or whatever that was.
Yeah, or verifying the identity or something. All right, so I've got a quotient rule, so that would be the derivative of the top, which is minus sine of x, times the bottom, so 1 plus sine x, minus the top, cosine x, times the derivative of the bottom. 1 goes away, derivative of sine of x is cosine of x. All over the bottom squared. I leave that as a unit, 1 plus sine x, and that whole thing squared. So then now we multiply, simplify, whatever you want to say. So negative sine x minus sine squared of x minus cosine squared of x all over 1 plus sine of x squared. So once we've done the first step, which is the calculus part, then we kind of go back to what you were talking about, like simplifying, verifying identities. So, any idea what I can do now that I'm here?
You can make that, wait.
I honestly would have maybe factored out a, no, that would be stupid, because that's right back to, never mind, you know what I was gonna say.
Well, 1 plus sine squared of x, that's cosine, right?
Oh, isn't like.
Like, you're talking about the denominator?
Isn't
No.
isn't negative sine squared of x minus cosine squared of x? Would that be negative 1?
Yes, so what should I do?
So we,
Factor out a negative first.
And then you do that with the 1.
So sine x plus sine squared x plus cosine squared x.
it's really smart. You for the 15 green.
What sine squared plus cosine squared?
1.
So I have negative, and then in the box sine x plus 1 over 1 plus sine of x squared. Now what?
So I guess we can
Take away.
cancel some things and whatnot. Do like
Sine of x plus 1 is the same as 1 plus sine of x, right?
I think so.
So I can get rid of this, take away that one, and be left with negative 1 over 1 plus sine of x. So what you're going to notice is these problems get a little longer because we're now dealing with trig functions. Just as a refresher, sine squared plus cosine squared equals 1. 1 plus cotangent squared of x, or well, I'm just going to say cotangent, equals cosecant squared. And tangent squared plus 1 equals secant squared. Those things will come in handy for you to know. So it seemed like a good time for a refresher.
I agree.
because we have a derivative that is cosecant squared, right? And I have one that's secant squared. So those may be helpful to rewrite things sometimes in terms of simplifying later on. All right, the next one's a weight hanging from a spring. Oh, that sounds familiar.
Sounds like we did physics.
Pops up and down with a position function s equals f of t, s in meters, t in seconds. What are its velocity and acceleration at time t? Describe its motion. So 12, position, so s equals 7 cosine of t. So how do I find velocity?
I mean, it's a derivative of
Yep. So what would the derivative of this be?
that. 7, wait, negative 7 sine of x?
Yeah,
I
it's g.
mean,
But yes.
Whatever. That's
If this was the AP thing, you get that wrong.
Then acceleration is what?
The derivative of that.
Which would be?
is, negative 7 cosine of t.
Yep. All right. A body is moving in simple harmonic motion. Okay, we know what that means, right? So, with position function s equals f of t, A, find the body's velocity, speed, and acceleration at time t, and then find all of those things at time t equals pi over 4. So basically, we're going to take all of our derivatives, solve those things out, find each of those, and then we're going to plug in a value. So 16 s equals cosine of t minus 3 sine of t. Now, what do we know about, or well, let me rephrase. I'll ask that in a second. I'm going to line these up so that I can do velocity and then work it all the way down. So like A and B will be like here together. Speed and acceleration. Just to make it easier to understand and not have to rewrite so much. So we said in the last problem, velocity is the derivative of position. So what would the derivative of the position function be here?
Negative sine of t
You got this.
minus 3 cosine of t.
Yep. Now what about speed?
It would be
Absolute
sine
value.
of t plus 3 cosine t.
Yeah, so I would just do this for the sake of time because once we find in part B, once we find velocity, then I'm just going to say absolute value of whatever that number is and get the answer. So you don't even need to rewrite it. Just show that it's the absolute value of your velocity function is sufficient on that for me. Now, when you get to the AP exam, I'd probably write the whole function in the absolute value bars if they ask you that on a short answer question. But for this, it's sufficient for you just to put v of t in absolute values, not have to rewrite it again. So now, what is my acceleration function?
Negative cosine of t plus 3 sine of t.
Yep. So now I'm evaluating this stuff at pi over 4 because that's what they told me to do. So v of pi over 4. This is why I said you need your unit circle. So I've got negative sine of pi over 4 minus 3 times the cosine of pi over 4. So what is the sine of pi over 4?
Square root of 2 over 2.
Yep, and the sine function is negative, so I'm going to put a negative in front of that. So negative root 2 over 2. And then I've got minus 3 times cosine of pi over 4.
Root 2 over 2.
Root 2 over 2. So don't forget 3 in front. I almost forgot it. So minus 3 root 2 over 2. Then I can combine these if I want to because they are common denominator. So negative root 2 minus 3 root 2 is?
That'd be like 2 root 2. Like negative 4 root 2.
Negative 4.
Yeah.
There we go.
So negative 4 root 2 over 2. So keep in mind, like I said, I can only do that because they had a common denominator. And these were both root 2's. So in order to do that, we have to treat whatever's in the square root like an x or whatever. It's like apples and oranges kind of thing. I'm sure y'all know that, but as a refresher. So then I can reduce this, and I would get
Negative 2 root 2.
negative 2 root 2. So what do we know about that? What does a velocity that's negative mean?
Go backwards.
It's going left or down, whatever.
Backwards.
All right, so speed would just be the absolute value of negative 2 root 2, which would just be 2 root 2. Then acceleration, so a of pi over 4, so negative cosine of pi over 4, plus 3 sine of pi over 4. So that's going to give me negative root 2 over 2 plus 3 root 2 over 2. When I combine that, what do I get?
Got this, Virginia.
I'm still writing it down.
Anytime Josh is like, you got this, Virginia, I always think he just doesn't actually know and just wants you to take it.
Exactly. Half the time, it's just to give himself more time to think. That's
No,
what-
I'm giving you a chance to answer.
No, I told you. That's what I'm thinking every time you say that.
I know you don't need chances to answer because you can answer things all on your own. I just think it's a nice gesture.
I answer a lot. Half the time.
Yeah, I know.
Half
That's
the
why I
time
said I
it's
know you
right.
don't need
Half
to
the
be
time-
given a chance to answer.
Half the time I get there. Sometimes I don't.
All right, one more, and then that's where we'll stop for today. I will go ahead probably and like write down the problems, but you don't have to do them until when we finish the section. So the last thing that we're going to do today is a body is moving in simple harmonic motion with position function s of t. Find the jerk at time t. So jerk is the derivative of acceleration. So if I start with position, I'm going to have to work my way all the way down to get there.
Oh.
So s equals 1 plus 2 cosine of t. So I got to find velocity first. So velocity is
Negative 2 sine of t.
Yep. Josh, acceleration.
I'll let you take this one, Josh.
Negative 2 cosine.
And
Make sure you write
jerk.
the S before the T.
2 sine of t.
Yep. So that's ultimately what we were trying to find, but obviously we have to find the other stuff in between there. So sometimes in a word problem, they may ask you to like find the jerk at time t equals whatever. They don't really typically ask you for jerk until we get into trig functions, just because it kind of like just keeps going. But anyways. All right, I'm going to stop there. There's only a couple more problems, but they're a little more in-depth, and I don't want to get started with them. They're like finding the tangent and the normal. And when I say finding the tangent, like tangent to the curve, like what we've been doing, but now involving trig functions. So, anyways, but your problems, if you want to go ahead and have them, 1, 5, 9, 11, 13, and 19.